the basics of the transformation of numbers into the different number system, like n equals 278. Here in the decimal system we have to use the base 10. So for 278, here 8 is in the unit place, 7 is in the tens place, and 2 is in the hundred place. So here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10 different symbols. So n equals 278, which implies that n equals 2, a2 equals 2, a1 equals 7, and a0 equals 8. So here 278 equals 2 into 10 to the power 2. Same for 7 into 10 to the power 1, and plus 8 into 10 to the power 0. Like n equals an rn plus an minus 1 r to the power n minus 1 plus dot dot plus a1 r1 plus a0 r0. In B example, n equals 1001 to the base 2. Here we are using the binary operation for the base 2. So here symbol 01 will be used, and n equals 1001 to the base 2 gives n equals 3. So here a3 equals 1, a2 equals 0, a1 equals 0, and a0 equals 1. So 1001 to the base 2 is written as 1 into 2 to the power 3, 0 into 2 to the power 2, same 0 into 2 to the power 1 plus 1 into 2 to the power 0. Same n equals 263 and to the base 8. This is in octal number system. R equals 8, the base is 8. So here symbol 0, 1, 2, 3, 4, 5, 6, 7. There are 8 different symbols, and we will use 263 in the 3 places to the base 8. 2 into 8 to the power 2 plus 6 into 8 to the power 1 plus 3 into 8 to the power 0. Like n equals 263, this is the hexadecimal numbers. So here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Actually for the number and digit greater than 9, we will use A, B, C, D, E, F. So here A stands for 10, B stands for 11, C stands for 12, D stands for 13, E stands for 14, and F stands for 15. So here we have to take the number less than 16 and lesser by 1. So here n equal to 263 to the base 16 gives n equals 2. So a2 equals 2, a1 equals 6, and a0 equals 3. So 263 to the base 16 equals 2 into 16 to the power 2 plus 6 into 16 to the power 1 plus 3 into 16 to the power 0. So here we are just forming the binary, hexadecimal, binary, octal, decimal, binary, octal, hexadecimal numbers. Here is a chart. You can see this is decimal number system, this is binary, this is octal, and this is hexadecimal, and we are just taking some digits, and here is the binary operation for that digit or for that numbers. This is the octal number system, and this is the hexadecimal number system. So as we discussed that 15 stands for F, 14 stands for E, 13 stands for D, 12 stands for C, 11 stands for B, and 10 stands for A. So there are also non-positional number systems. For example, Roman number system. In our childhood, we have already gone through this number system. This is Roman number system. Relation between binary number system and others, binary and decimal. Converting a decimal numbers into binary, decimal to binary. Divide the decimal number by 2 and take its remainder. The process is repeated until it produces the result of 0. The binary number is obtained by taking the remainder from the bottom to the top. Like when we are transforming decimal to binary, in this case 5310 gives 53 by 2, 26, and the remainder is 1. Same 26, this number will be divided by 2 because we have actually 2 is the base for binary operation. So here we have to divide by 2. So 13 and the remainder is 0. Same 13 by 2 and 6, the remainder is 1. This is the quotient and the remainder is 1. And same 6 by 2, the remainder is 0 and quotient 3. Same 3 by 2, the remainder is 1 and quotient is 1. Same 1 by 2, the quotient is 0 and the remainder is 1. So here we have to go from bottom to top to write the binary numbers. 110101 is the the binary number for 53 to the base 10. Same you can see there are 6 bits here, 110101. So for 0.81 to the base 10, binary is what? So 0.81 to the base 10 gives 0.81 into 2 is equal to 1.62. Same 0.62 into 2 equals 1.24. Same 0.24 into 2, 0.48. 0.48 into 2 equals 0.96. 0.96 into 2 equals 1.92. 0.92 into 2 equals 1.84 equals 0.1100112 approximately. And from top to bottom, 0.1100112 is the binary number of 0.81 to the base 10. Converting a binary number into decimal binary to decimal, multiply each bit in the binary number with the weight or position, add up all the results of the multiplication performed. The desired decimal number is the total of the multiplication result performed. Example, binary to decimal. Here in example A, 111001 to the base 2. There are total 6 bits. So 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3, same 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So here 32 plus 16 plus 8 plus 0 plus 0 plus 1. So 57 is the total, the sum of the numbers. So here 57 to the base 10 is the binary transformation from 111001 to the base 2.